Welcome, welcome, welcome. I am so happy to see you. As always, if you're new here, well, then this is where we take Hollywood and sprinkle it with a bit of common sense and see what comes out the other end. To all the rest of you, welcome back. You know what you're getting yourself into.
Today we are gonna take a look at how Hollywood thinks stuff move around in space. Quick spoiler, they get it wrong pretty much every time, but I'll get back to that.
First, a little disclaimer. You may think this video is fabulous and genius and everything is cool. Well, in that case, thank you. I am very flattered. It is just fab, but it's not unique. It's heavily inspired by another creator called Shad over at Shadiversity. He did a video on the same topic. I'm not adding much to the conversation as he goes into very great detail in his video. I'm just kind of shaping the information to suit my content and the videos on this channel. If you like this video, I would highly encourage you to go watch his on his channel. Link in the description. Oh, it's down below. With that said, let's jump into it. To do that, we need a spaceship, and as it happens, I don't have one. That's why I went and bought a disassembled one. I don't know if you can hear it, but it's not really worth much in its current condition. So let's go and undisassemble it. That's a word, right?
Okay, we are ready. And by the magic of editing, we have a ship. For reference, this is how Hollywood would like you to believe stuff moves in space. It breaks pretty much every single law of physics. I don't think Hawkins would appreciate this.
To understand why that is wrong, we have to dig up good old Newton and his 3 laws of motion. I'll try and make it as interesting as possible because this is kind of a dry subject. But let's try to do it. Newton's first law states that, and I have to read it, every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the act of an external force. That is very fancy talk for how difficult it is to get something to move or how difficult it is to get something to change direction while it's moving. It's called inertia. As an example, let's say that you're sitting on an asteroid somewhere in space, doing nothing, just hanging, chilling, maybe even listening to some music, when some wanker comes along in a spaceship honking his horn at you. He's just ruined the moment. We've all been there. It's a bitch and it's annoying. You get so frustrated at him that you pick up your favorite onion, and you throw it at him as he passes you.
When your onion hit his ship, you can see that the onion bounces off and floats away, but you can also see that his ship starts to drift slightly. And that is Newton's second law. You have just changed the momentum of his ship by applying an external force. In this case, your prized onion. How much you've changed it depends on the momentum of the spaceship onion conglomerate, which conveniently is Newton's third law, that states, for every action in nature there is an equal and opposite reaction. In other words, pull.
A little bit simplified, you can look at inertia as how difficult it is to get something to move, and momentum as how difficult it is to stop it again.
With that said, let's try and work out how spaceships in Hollywood break these 3 laws. To begin with, I want to clear a common misunderstanding. The small thrusters on the side of the spacecraft, the ones you see here, they are not there to change the direction of motion. All they do is orientate the spacecraft. Let's say you're cruising along, just enjoying Newton's first law, and want to take a pit spot. Pit spot? What the hell is a pit spot? Screw it, I'm gonna go with it. It's not a pit stop. Right now, it's a pit spot. So you want to take a pit spot somewhere. To stop, you would either run your engine in reverse, which is impossible, or you would turn your ship 180 degrees and fire up the main engine until you have stopped. Now you're ready to go get a cup of interstellar tea and maybe hit the subscribe button. Who knows, maybe you get an extra biscuit or something. Let's look at a simple motion, one they do in pretty much every sci-fi space movie repeatedly. It is a turn. I know, fancy, right? How it looks in Armageddon is something like this. Let's put a few numbers on the board for the sake of explaining. We are moving in this direction with 10 kilometers per second, and we want to end up moving in this direction at 5 kilometers per second. So, following Newton's law of motion, we have to apply some kind of force to change the momentum of our ship. As it so happens, we are in possession of an inertia applying apparatus. It's called an engine. One obvious way to do it would be to orientate the ship, accelerate in the opposite direction of motion until you reach 0 kilometers per second, reorientate the ship, and then accelerate to the required 5 kilometers per second in this direction. You have now completed a turn. If you at this point still don't understand what a turn is, then I will allow 5 seconds of being ashamed of yourself time, starting now.
Be ashamed of yourself, sweetie.
However, a better way of doing the turn would be to orientate the spacecraft such that the engine burn accounts for the change in both directions simultaneously. It looks something like this, and it saves a lot of energy. The reason being, you only have to change your velocity from 10 to 5 kilometers per second, not from 10 down to 0 and then from 0 back up to 5. One thing is definitely for sure, you don't do it like this, or like this, or like this, or this, or this. I think you get the point, right?
So how do all this break Newton's laws of motion? Well, let's start with the first law. Here we see an X-Wing from Star Wars. It can't swerve from side to side without an external force acting on it. Newton says no. The second law is broken here, where Kylo Ren is pulling some sweet ass moves in his fighter. There's a change in inertia without the force acting in the opposite direction. Newton says no. The third law is broken in Armageddon, where one of the space shuttles is hit by an asteroid without changing its inertia or momentum. Newton says no. All of this is pretty useless anywho, because no spaceship would ever do a 90-degree turn in space for several reasons. 1. You spend 99% of your fuel to get where you are now. You don't have enough to make a turn. 2. You can just slingshot around the Earth and punch the pedal at the right moment and be on your merry way, pretty much without spending any fuel. 3. If you need to make a very sharp turn, something has gone seriously wrong and you are probably dead anyway. 4. If you are 90 degrees off course, then you are an idiot and you should not be allowed anywhere near a spaceship. Or anything space related for that matter. To my right I have put another video where I talk more space stuff, so if you're interested in this video, well then you might like this one. To my left, the YouTube gods are in command. Also, what do you think about this concept of breaking down a theme across a movie genre? Let me know down below. See you in the next one.